This will be the second lesson on using the properties of logarithms. So our objective is going to be the same as the previous lesson, where we're going to use the properties of logarithms to simplify and solve. And it's based on these properties and also this rule where we take the log base b of b to the n, and that simplifies to just the exponent n, because that's the answer to a logarithm. So the three properties that we used before, that we developed in the last lesson, were based on the rules for exponents, and those rules basically took, and we can now simplify things based on these, where if we've got log base b of n times r, we can separate those two into two logarithms and make it log base b of n and added to log base b of r. So separate it out into two different logarithms added together. Now if we have division, n divided by r inside the logarithm, that can be separated instead into log base b of the numerator n minus log base b of the denominator r. That's where we're subtracting exponents in our exponent rules. And the last one is where we have log base b of n to the r, where you've got r as the exponent. You can bring that r down in front, like the power of the powers, and multiply it times the log, because the log is an exponent, and it becomes r times log base b of n. It's like multiplying two exponents together. So we're going to use these three properties in the rule in order to simplify different logarithms. So let's try this first one. And the first one, the idea is where we're going to take and we're going to separate, because it's multiplication inside the log, and make it the addition of the two logs, log base 5 of 25 plus log base 5 of 125. Now 25 is the same as 5 squared, and 125 is the same thing as 5 cubed. Now we can use the rule right above it that says that if you've got that base with those two bases to exponents, it becomes the exponent. So it's 2 plus 3 gives us 5 for the answer. Now the next one, part B, is going to be where we've got division, so we're going to subtract the two logarithms. So take the log of the numerator, log base 6 of 216, and subtract log base 6 of 36. 216 is the same thing as 6 to the third power, and 36 is the same thing as 6 squared. Now we use our rule above, and we can just simplify it to the two exponents. 3 minus 2 gives us 1 for an answer. Now the next part, what we're going to do is we're going to take approximations of logs. If we know that log base 4 of 3 is equal to about 0.7925 and log base 4 of 5 is about 1.1615, we're going to use those to simplify logs that aren't quite as easy to do. So this first one's division, so we're going to subtract the logs, log base 4 of 5 minus log base 4 of 3. Substitute in the approximations given in the directions there, so we'll have 1.1610 minus 0.7925, and when we subtract those we get 0.3685 for an answer. Now this is, again, an approximation, but what that means is 4 to about the 0.3685 power is about 5/3. Now let's go ahead and do the next one. We want to know 4 to what power is 15? Well, let's use our approximations to get this, and 15 we can use as 3 times 5. Use the numbers we're given, so 3 times 5. Now we can separate, since it's multiplication inside the log, becomes addition of the two logarithms, so log base 4 of 3 plus log base 4 of 5. Substitute in the values, add them together, and then we get a final answer of 1.9535. What that means is 4 to the 1.9535 is about 15. If you want to try that out, that's what the logarithm converts into. Now let's try this last one. Now this last one, 36 doesn't use the 5, but it does use a 3, and let's apply it to 4. We can use, since it's log base 4, let's use a 4 in the problem. So 4 times 9, because log base 4 of 4 added to log base 4 of 9, that 9 is the same thing as 3 squared. log base 4 of 4 to the first is just a 1. And then log base 4 of 3 squared, we bring that 2 in front, substitute for the log base 4 of 3, put in the number in the directions that it's approximately equal to, multiply it by 2, add it to 1, and you get about 2.585 for an answer. So it's a matter of simplifying with what we know and then simplifying it down using, in this case, some approximations. All right, now let's start doing solving equations. That's what's different about this next part, is the solving equations part. Before we were just simplifying expressions. So we're going to use the rules now backwards. This first one is a subtraction problem. So because subtraction was the result of two things being divided, let's bring them together into one log and make it log base 4 of 48 divided by n. So go backwards on the rule, equals log base 4 of 6. Now, if we have the same base on both sides, a base 4 on both sides, when that happens, we can then take the inside parts of the log, the 48 over n, and the 6, and set them equal, and then we can solve that as an equation. So if we've got 48 over n equal to 6, we solve that by multiplying both sides by n. That will get rid of the n in the denominator. And then we're going to get 48 equal to 6n, divide both sides by 6, and you get n equal to 8 as our solution. Now, it's important on these that you check your answers, because in this case, if you put that 8 back in and you would be taking the log of a negative, you wouldn't be allowed to do that as a solution. So you've got to have both the base and the inside of a log be a positive number. And in this case, it works out. So this next one, since it's addition, we're going to take the two things that are inside the logs and multiply them. So we take that 2x times 7. And on this case, the 2x times 7 is going to be 14x. Those are the inside parts of the two logarithms multiplied together. Now on both sides of this, they both are log base 3. Since the insides are the same, we can set the bases are the same, we can set the inside parts equal. So 14x is going to equal 28. If we divide both sides by 14, we get x equal to 2. That's our solution. If you plug it back into the equation, if you substitute it back in, it actually is okay. It works out. It gives you positive numbers inside the logs. Now this last one, notice it has a 3 in front of it. We're going to use that last rule to make that the exponent on the inside by working it backwards. So it becomes x to the third, bringing that 3 out in front. It's both base 2 on both sides, so we can set x to the third equal to 8. We can then take the cube root of both sides. We get x equal to 2. If you put it back in, it checks. It's a positive. It works out. We have our solution.